The Earth's magnetic field has always been one of our planet's most important defenses. It shields us from solar storms, deflects harmful radiation, and stabilizes the atmosphere so life can thrive. Yet, scientists know it is not permanent. Our field weakens, recovers, and flips direction in cycles that stretch across geological time. The next flip could already be on the horizon. But what happened just days ago has opened an entirely new question. What if forces far beyond our solar system can reach across millions of light years and touch Earth's magnetic shield? Magnetometers across the globe, instruments designed to track the smallest changes in magnetic energy, registered something extraordinary. A sudden spike. A jolt so brief and sharp that it could not be explained by solar activity. The sun was quiet, space weather reports were calm, yet Earth's protective bubble shifted. And when the data was compared across different stations, the source pointed toward a direction we did not expect: the Andromeda Galaxy. Andromeda is no ordinary neighbor. At 2.5 million light-years away, it is the closest large galaxy to our Milky Way. It is massive, containing over 1 trillion stars, countless black holes, and structures we still don't fully understand. Yet somehow, something from within it may have left a signature on Earth. If true, this completely rewrites our understanding of where space weather begins. It would mean that not only our Sun, but distant galaxies themselves, can influence life on our planet. The event was not dismissed as random noise. Multiple independent systems caught it. Ground-based magnetometers from NOAA. ESA's swarm satellites orbiting Earth. Even quantum-level instruments in research labs, capable of detecting the faintest magnetic tremors. All of them agreed. The spike was real, and it carried a unique fingerprint. That fingerprint was a repeating frequency. A signal pattern. The kind of precision that does not come from chance. It appeared first as a faint radio burst from the direction of Andromeda. Then, exactly 2.3 minutes later, the magnetic field of Earth twitched in resonance. That delay matches the time it takes for a disturbance at the edge of our magnetosphere to ripple down to ground-level sensors. In other words, the sequence was too perfect to ignore. Imagine Earth's magnetic field as a drum stretched around the planet. Normally, the sun is the drummer, beating on it with solar winds and storms. But what if another drummer, unimaginably far away, struck the drum at just the right frequency? Even across millions of light years, the drum would still respond. This is the power of resonance, not brute force, but precision. And this is not the first time we've seen such an effect. In December 2004, a magnetar in our galaxy flared with unimaginable energy. For a fraction of a second, this dying star released more power than our sun emits in hundreds of thousands of years. Satellites were blinded. Yet the most remarkable thing was this: Earth's magnetic field pulsed in perfect synchronization with the magnetar's spin rate, 7.5 seconds. Our planet's field rang like a struck bell, echoing a heartbeat from 50,000 light-years away. Now, scientists believe something similar may have just happened again, but this time, from 50 times farther. The implications are staggering. To explain it, 3 main theories have emerged. Theory 1. Resonance triggering. Just as an opera singer can shatter glass by hitting its exact note, even a weak cosmic pulse can shake Earth's magnetosphere if it lands on its natural frequency. The power doesn't need to be enormous, the precision is what matters. Theory 2. Intergalactic magnetic bridges. Galaxies do not float alone in empty space. They are connected by vast cosmic filaments, threads of magnetized plasma stretching across the universe like invisible highways. These structures can carry signals across millions of light years without scattering them. If Andromeda released a pulse, it could have traveled along one of these filaments, focused and coherent, until it reached Earth. Theory 3. Advanced detection. Our new instruments are far more sensitive than anything that came before. Quantum magnetometers, AI anomaly trackers, and atomic sensors are capable of hearing cosmic whispers that older devices simply ignored. Perhaps these events have always been happening, and we are only now beginning to notice. But here's the unsettling part. The frequency pattern detected doesn't match any known cosmic source. Not solar flares. Not pulsars. Not catalogued magnetars. It is new, structured, and mathematical. The radio signal repeated every 3.7 seconds. The magnetic spike lasted 12 seconds. That's a perfect 3-to-1 ratio, too precise to dismiss as coincidence. So, what could create it? Inside Andromeda, 3 candidates stand out. First, a magnetar flare. Andromeda may host over 100 million neutron stars. If even one of them released a burst, it could explain the timing pattern. Second, the supermassive black hole at Andromeda's center. It is quiet now, but even a small flicker of activity could produce transients powerful enough to send structured signals through the cosmic web. Third, dark matter. Observations of Andromeda have revealed mysterious X-ray emissions that don't fit our known models. Some physicists believe dark matter interactions could create periodic fluctuations, waves that ride intergalactic filaments and survive the long journey to Earth. This may sound abstract, but the real-world implications are anything but. Our modern world is tied to magnetic stability. GPS satellites rely on precise orientation data. Airlines use magnetic navigation systems. Power grids monitor fluctuations to prevent overloads. Even high-frequency trading in global markets depends on timing signals that assume stability in Earth's magnetic field. Now imagine subtle, unexpected nudges from intergalactic space. Not catastrophic disruptions, but small drifts, timing errors, induced currents that stack with ordinary solar effects. A trading system loses milliseconds. A plane's navigation drifts by fractions of a degree. A power line surges unexpectedly during a quiet solar day. These are the vulnerabilities researchers are now beginning to consider. This is not about fear. It is about awareness. The more we understand, the better we can design systems that adapt instead of fail. The key question remains: was this a rare, one-time anomaly, or are we only just beginning to notice a hidden cosmic rhythm that has always been there? To answer, scientists propose a roadmap. First, compare magnetometer data from across the world down to the second. If the same pattern appears everywhere simultaneously, it strengthens the case for an external source. Second, scour radio and X-ray archives for signals from Andromeda during the same window. Third, simulate how plasma filaments might carry coherent signals across intergalactic space. Fourth, look for other events during quiet solar periods. And finally, make the data open, so independent researchers can test, verify, or challenge the findings. This approach is about more than solving one mystery. It could reveal an entirely new layer of how galaxies communicate across the cosmic web. And perhaps this was not a single call from Andromeda. Preliminary reports suggest a second detection window, pointing toward another galaxy entirely, may already exist. If that holds true, we are not looking at one accidental alignment. We are looking at a universal phenomenon. A hidden network. A galactic rhythm that links worlds, stars, and galaxies together in ways we are only beginning to hear. For the first time, we may be learning that Earth is not only a planet orbiting a star, but a participant in a vast, interconnected symphony that plays across the universe.